Hello, this is Mr. Henry, and welcome to lesson 6.4. Today we're going to be looking at compound inequalities and solving and graphing with multi-step stuff and the multiplications and the divisions. And so it's a combination of a bunch of stuff we did before and a little bit of new stuff, these compound inequalities. So central question says, how do I solve compound inequalities? And we have one get the goof problem here. So let's see how this goes. In fact, what I'm going to do is I'm going to take this guy. That's the wrong button. I'm going to take this guy and just kind of bump him over here. And I'm going to do the problem the way that I would do it, just over here off to the side. And I'm going to see where we get a difference instead of looking through each individual little step. So the first thing I would do is I have variables on both sides. I would get rid of the one on the right. So I'd minus 2x here. These cancel out. I'd get a 4x minus 7 is less than 17. They got rid of this thing first, which not necessarily bad, but kind of bad. And let's see, the next step we would add 7 to both sides. You get 4x is greater than 24, and that's where I see a mistake, because they should have added 7, and you're not going to get a 10. So that right there is a big boo-boo. Then you would divide by 4, and x is greater than 6. And it doesn't really have a number line and a graph stuff, so we don't have to do that. But you would graph and number line. Here we have 3 new vocab. So first off, a compound inequality. A compound inequality is 2 separate inequalities that are combined together using the words and or. So it's kind of like 2 math problems wrap up together in one. It's almost like a compound sentence. How you say, I went to the store, I went home. Those are 2 separate sentences, but you can combine them together using the word and. I went to the store and I went home. It's the same deal. You're combining 2 separate inequalities into one. When you have and, you're looking for the solution of both inequalities. And inequality means both of them have to be true. Both of them have to be correct. An or inequality is when the solution of at least one of them. So when you have an or, one or the other could be correct, and both parts have to be true. May not make a lot of sense right now. It'll make more sense when we start getting into the actual lesson. Okay? So for now, copy it down, and it'll make more sense here coming up shortly. Compound inequality. So when we're talking about these and, so here we have x is greater than negative 2 and x is less than 1. Well, let's start by graphing this. I'm going to graph the blue guy in blue. So well, let me get a number line. So 0, 1, 2, negative 1, negative 2. Alright, so in blue we would have a hollow dot at 2, and we'd be shading greater than. So all this stuff in blue is the solution to the x is greater than negative 2. Okay? In red, I'm going to graph this red guy. So I need a solid dot at 1, and I need to shade everything less than 1, which would be all of these things. Now, because this is an and, what we're looking for are where both of them true. So where do I have answers that are bigger than negative 2 and less than 1? Well, bigger than negative 2 and less than 1 is in this overlapping region here. Meaning negative 1, for example, it's bigger than negative 2 and it's less than 1. 0. It's bigger than negative 2 and less than 1. So when you have an and inequality, You're looking for the overlapping region. So the answer would be, I'm just going to pretty that part up a little bit. The answer would be this. You'd have a hollow dot at 2, a solid dot at 1, shaded in between. That shows all the numbers that satisfy both inequalities, bigger than negative 2 and less than or equal to 1. Now, an OR inequality, either of them could be true. So let's put a number line. 0, 1, 2, negative 1, negative 2 works. I'm going to do this guy in blue, this guy in red. So blue, we're going to look for numbers that are bigger than 0, bigger than or equal to. So I need a solid dot at 0, shaded, greater than. In red, we need a hollow dot at negative 1, and we're shading less than to the left. You'll notice that these two lines do not crisscross. That's okay. This is not an AND, where both of them have to be true. An OR inequality is when one can be correct or the other can be correct. It doesn't matter, so we highlight both answers. So the answer here is literally all of this stuff bigger or less than negative 1 and bigger than 0. The only numbers that are not answers are from negative 1 up to the round 0. I mean, 0 is an answer, so less than 0 to negative 1. Those are the only numbers that are not solutions to this problem. So as we're solving today, we're going to see problems where we get solutions like these, and then we're going to have to graph them. Okay? So, here we have, it says, write and graph compound inequalities. So, all real numbers that are greater than negative 2 and less than 3. So let's think about that first. All numbers that are bigger than negative 2, so numbers bigger than negative 2, greater than negative 2, and less than 3, numbers less than 3. Okay? This is a compound inequality. We have two possible solutions that we can graph on our number line. I'm going to have to count by 2's to fit them all in here. So I'm going to just put negative 2, 0. Yeah, that'll work. Negative 2, 0, 2, 4, and negative 4. Now, when you're going to graph these, here's how it works. You're going to put the dot at each of them, the correct dot. So at negative 2 here, I need a hollow dot because it's just a greater than. At 3, I need a hollow dot, and 3 is between 2 and 4. Now, both of these problems, you have to look very carefully to see which direction you shade. So here, n is greater than negative 2. So I'm going to be shading numbers bigger than negative 2. Now this part I usually do a little light if I'm using pencil, because I don't know exactly what it's going to look like yet. So I'm shading, actually, let me fix that. I should go like this. Just make a little, I'm shading this way of this dot. N is less than 3. And I shade this way of this dot. So I'm shading this way here, this way here. I'm going to have this overlapping region. That is my answer. So I have a hollow dot at negative 2, a hollow dot at positive 3, shaded in between. Now, I want to show you one other way to write this compound inequality. Put the numbers in order from least to greatest, so negative 2, 3, with your variable in the middle. Now, look at how this goes. From n, we shaded that way of 3. We shaded less than 3. And the n, we shaded bigger than 2. Look how it's facing the n. It's facing the n. this is more than likely how you're going to see the problems written in a textbook, on worksheets, on note sheets, that kind of stuff. The reason why is it takes up less space. It's once you get the hang of it, this is just as easy to use as this. So it takes up less space. It's a little bit simpler. Letter B. Letter B says all real numbers that are less than 0, so numbers that are less than 0, or greater than or equal to 2, so numbers that are greater than or equal to 2. And this was an OR. Now, first off, let's do our graphing. I'm going to put 0 here, 1, 2, 3, and that'd be a negative 1. I need a hollow dot at 0. I need a solid dot at 2. And it's not good enough to always just go, oh, well, you're going to shade in between them. No. You actually literally have to check out both inequalities and see how they shade. So n less than 0. It's less than, it looks like an L. You shade to the left. So I'm going to shade this way of this one. N is greater than or equal to 2. Greater than, we shade this way. So in this problem, we're actually shading on the outside of them. So we shade here and all of this. When you have an OR inequality, you cannot write it as one long line like this. We usually just write like n is less than 0 or n is greater than or equal to 2. I mean, this would be the way to write it. With an AND, you can write it without the AND by combining the two parts into one problem, or stays separated into two separate problems with an OR in between. Okay? There's one problem I'd like you to try. This is letter C. Go ahead, copy it down, do it on your paper, and then we will do it together in just a second. Okay, it says all real numbers that are, so numbers that are less than or equal to -3, and numbers that are greater than or equal to -8. Okay, I'm thinking about my scale. I'm thinking counting by 2's, -2, -4, -6, -8, -10. That'll work. -2, -4, -6, -8, -10. Remember, these numbers down this way are getting smaller. So -3 is right there. We need a solid dot. -8 is right there. We need a solid dot. And ands usually mean we're going to be shading in the middle. Ands you shade in the middle, ors you shade on the outside, usually. But let's double check it. We need less than -3, so to the left of -3, this way, greater than -8, and it checks out. This was an and we shaded in between. As the compound inequality, again for these guys, you wrote the numbers in order from least to greatest with the variable in the middle, and then you just put down the proper sign. So look, from the n and the -3, it's facing the -3. The n and the -8, it's facing the n. There we go. This is the same thing as all of that, just a bit simpler. Now, there are two problems from the textbook I'd like you to try. These come from page 380, numbers 1 and 2. Go ahead, copy the problems down, do them on your paper. If you need help, you can hit play and get yourself caught up, or if you're done, we can go through them together. Okay? So let's see. Number 1 says all real numbers that are, so numbers that are less than -1 or greater than, I wanted to put my variable, greater than or equal to 4. Less than -1, greater than or equal to 4. 0, 2, 4, -2, -4, -1 is right there. I need a hollow dot at -1, a solid dot at -4. I'm sorry, at +4. We're shading less than -1 to the left, L left, less than. And we're shading greater than +4, which is this way. That is number 1. That's the graph of this. And this is the inequality. Number 2, all real numbers, so numbers, that are greater than or equal to -3 and the number is less than 5. Now again, let's combine this into one thing. So -3, 5, smaller, bigger, variable in the middle. It opens towards the 5. It opens towards the n. This way is the preferred way. Okay, to graph this, let's see, scale. Counting by 2's is not enough. So let's count by 4's. So 0, 4, 8, -4, -8. We've got -3 here. We've got +5 there. +5 gets a hollow dot. -3 gets a solid dot. And I am shading less than 5. N is greater than -3. So I'm shading the stuff in between. Okay, so these problems have just been writing the inequalities and then graphing. We haven't actually got to solve any yet, which is the very next thing we're going to do. So look at example A here. We have this inequality. Now you'll notice we have two inequalities, two signs in the middle of the same problem. This is one of those ands, like this, where it's two separate problems combined into one. Very simply, all you do is you just treat this thing like it has three sides. It has three sections of the problem. You still want to get the variable by itself, so you do the same steps. Here, to get rid of this variable by itself, you're going to add 3. But you don't just add 3 here, you have to add 3 to all the sides. So I'm going to add 3 there, add 3 there. This side gives me a -2 is less than or equal to 2x is less than or equal to 4. Now, to get my variable by itself, I need to divide by 2. But again, not just here, everywhere. So these canceled out. I get x. Over here, we get a -1. On this side, we get a +2. And now, we graph this. 0, 1, 2, -1, -2, solid dot at 2, solid dot at -1, and this is an and, so we're probably going to be shading in between. Less than 2, bigger than -1. Less than 2, bigger than -1, so this stuff in between. Letter B. Now you'll notice here this problem looks a lot longer. That's because it has this or, which completely separates this problem into two very different problems. And you solve each problem independently. You solve the problem on the left completely by itself. You solve the problem on the right completely by itself. But then you graph both answers on the same number line. So let's just solve this letter B over here. So we're going to subtract 3 on both sides. 6, divide by 2 on both sides. X is less than 3. So we solved this one. Now we're going to solve this one. We're going to add 6 to get rid of him. 3x is greater than 18. Divide by 3, divide by 3. These cancel. X is greater than 6. Now, We've solved both inequalities. Now we're ready. We can graph both of them just on the same number line. So this guy gets graphed here, and this guy gets graphed here. So, sure, I was going to do 2, 4, 6, 8, 0. I like to have these numbers about centered, so that puts me with a 3 here and a 6 there. 6 needs a hollow dot. 3 needs a hollow dot. Ors almost always shade on the outside. Well, let's check. X is bigger than 6. That way's bigger. X is less than 3. That way's less than 3. And we did shade on the outside here. Okay? We'll see one more example that we'll do together, and then I'll have a problem for you to try on your own. This is letter C. Now, letter C, if you look at it, it is a compound with the two separate inequalities in the same problem. I'll make them a little invisible for us so they're not quite so bold. There. Now, whoa, I don't know what he did. That's fine, whatever. Now let's do. So to solve this, we're going to add 5 to all sides. That gets rid of him. So we're left with a 4x in the middle. 7 plus 5 is 12. Negative 5 plus 5 is 0. One thing I notice a lot of people is they have a problem putting down 0 as a number. They think, oh, something cancels out here. I don't know what to put here. Well, you get the number 0, so just put 0. And then we divide by 4, cancel, divide by 4, divide by 4. What do we get? Well, in the middle, we have just our variable. Everything else canceled out. Here we have a 3. Here we have a 0. I don't know what that was. It was a circle, but I don't know why I did it. Now here, let's graph. So we got 0, 1, 2, 3, and we'll call that a negative 1. We need a hollow dot at 3, a hollow dot at 0, and an and is probably going to be shaded in between. Let's see. Less than 3. X is bigger than 0. It's in between. All right. I would like you to please do letter D right now. Pause the video, do it on your own. When you're ready to continue, hit play, and we will go through it together. Okay, you should be done by now, so let's see. With an OR, you completely do the problem separate. So let's do it. This side, we're going to minus 4 on both sides to get rid of him. 3m is less than 6. We would then divide by 3. These cancel. M is less than 2. Okay? On this side, m minus 5. Okay, so we would add 5. M, and these cancel, is greater than 10. Well, that was easy. That one's done. The variable's by itself now. So let's graph them. On our number line, we got from 2 to 10, 2, 4, 6, 8, 10. That'll work. 2, 4, 6, 8, 10. Okay, let's graph this one in red. So we need a hollow dot at 2, shaded to the left. L, left, less than. The other guy here, the one in green, we need a hollow dot at 10, and we're shading to the right. It's pointing to the right, so we shade this way. And that's what we would get. So we had two separate problems. We solved each problem separately, but just graphed them both on the same number line. Two more examples, letters E and F. Please do these two problems. Pause the video. Do them on your own as much as you can. When you're ready to continue, hit play. We'll go through them together. Okay? So let's see here. So those are my dividing lines. And now to solve, we would minus 3, minus 3, minus 3. That gets rid of him. So we get 2x. This side, we get a negative 4. This side, we get a negative 8. And then divide by 2. These cancel. And we get a negative 2 here and a negative 4 there. One thing you might be curious about, you might be asking yourself, is what would happen if I would divide by a negative 2 here? So if this was a negative 2x and I divide by negative 2 everywhere, would I still have to change the direction of the inequalities? And the answer is absolutely. Since you would divide by a negative 2, you'd change the direction of all the inequalities in the middle of the problem, just like we've done before. Okay, I think we're ready to graph this guy. So let's see. Negative 1, negative 2, negative 3, negative 4, negative 5. Solid dot at negative 2. Solid dot at negative 4. This is an and, so we're probably shading in between. Less than negative 2, bigger than negative 4. Yep. That's the answer for letter E. Letter F, we need to, well, we've got our two separate sides again, so I'm going to separate. Alright, so we need to add 3 to cancel him out. So we add 3 to all the sides. So we get a 3m in the middle. On this side, we get 6. On this other side, we get negative 6. Divide by 3 to get the m by itself. Divide by 3 on all the sides. So 6 divided by 3 is 2. Negative 6 divided by 3 is a negative 2. And we're ready to graph. 0, 2, 4, negative 2, negative 4. So we have a hollow dot at 2. Whoa. We have a hollow dot at negative 2. Ah, man. Sorry about that. So we got a hollow dot at negative 2 and positive 2, and then we're going to shade in between. Okay. The next couple problems come from the textbook. These are numbers 7 through 10 on page 382. Go ahead, pause the video, copy them down, do the problems, get the practice. When you're ready to continue, hit play, and we'll go through them together. Okay, let's see how we did. So, number 7. Negative 14 is less than x minus 8, which is less than negative 1. We have those two different inequalities in the same problem, so we're just going to separate. So I'm going to add 8 here, and here, and here. So these canceled out in the middle. So we have x is less than 7 on this side, and x is greater than negative 6. 6 and 8 and 14. Yeah, that works. So we need to graph the numbers between negative 6 and 7. So we need a kind of a bigger scale. I'm thinking counting by 4s again. 0, 4, 8, negative 4, negative 8. With 7 being here and negative 6 being there. Hollow dot at 7, hollow dot at negative 6, and we shade in between. Number 8, negative 1 is less than or equal to negative 5t plus 2 is less than or equal to 4. We have the and, so it's the two separate sides. So we're going to add, I'm sorry, not add 2. We're going to subtract 2 to all three sides. These cancel out. We get 4 minus 2 is 6. No, 2. Yeah, I can math. And negative 1 minus 2 is negative 3. To finish solving this, we have to divide by negative 5 on all three sides. And I don't know if you caught that. We're dividing by a negative 5. When you divide by a negative, you change the directions of the inequalities. So this guy changes to a less than. The greater than changes to a less than. Now we're going to get some funky decimals here. These decimals aren't terrible, so let's just put the decimals. This gives us a negative 0.4. This gives us a positive 0.6. How would we want to graph this? Yeah, 0, 1, 2, negative 1, negative 2. I'll do the way I've been doing it, using the putting the whole numbers and then a decimal just gets a line in the middle. So there's 0.6. That would be, actually be over a little bit more, like there. Negative 0.4. Both get solid dots, and it's an and, so we're shading in between. And there we go. Now, if you need to see 7 or 8 anymore, make sure you pause the video and get it copied down. I'm going to erase them to do 9 and 10 in the same space. So this was 7, 8, 9 will be down here, 10 will be down here. Okay, so number 9. Now look at it. We have two separate problems separated by or. So we literally just solve each one independently. So minus 1, giving us 3h is less than negative 6. Divide by 3, divide by 3. These cancel. H is less than negative 2. On the other side, we would start by adding 5 to both sides. And you'll notice I am going a little bit quicker because, well, we've done like a bazillion of these things by now. So if you're not familiar at this point, you need to go back to the basics and look at some of these other videos. By now, you should be working through these problems pretty quickly and understanding how to solve an inequality or how to solve an equation. We have two separate answers. We're just going to graph on the same number line down here. So we need it from negative 2 to positive 6, negative 2, 0, 2, 4, 6. That'll work. 2, 4, 6. We need a hollow dot at 6, a hollow dot at negative 2, and it's an or, so we'll be shading on the outside, probably. Greater than 6, less than negative 2. Done. Number 10 is also an or, so two separate problems, solving independently. Subtract 1 on both sides. 4c is less than or equal to negative 4. Divide by 4, divide by 4, cancel. C is less than or equal to negative 1. And on the other side, add 3 to both sides, giving us 5. C is greater than 20. Divide by 5, divide by 5, cancel. C is greater than 4. 4, 3, 2, 1, 0. So I have to count by 2's. So we'll do negative 1, negative 2, 0, 2, 4, negative 4. I need a point at negative 1, which is between 0 and negative 2. So there's negative 1 with a solid dot. And 4 gets a hollow dot. And it's an or, so I'm shading on the outside. Bigger than 4, less than negative 1. That is solving compound inequalities. And is in between, or is on the outside. Now let's get some couple little application problems, and then we're done. Application says the temperature on Mars has a max of 27 degrees Celsius and a minimum of a negative 133 degrees Celsius. Write and graph an inequality for the temperatures on Mars. Okay, well, the biggest is 27, so it has to be less than or equal to 27. That's the biggest possible temperature, so it's anything from there down. I'll use a T for temperature. And the minimum is negative 133. So it has to be bigger than or equal to negative 133. I got this guy. Now, if you wrote it as two separate ones, you'd write like T is less than or equal to 27 and T is greater than or equal to negative 133. But if you'll notice, this is the same thing. These two combine together to give you that, the way we did earlier. So then we would graph this thing, and what would I want to count by? I think I want to count by 50s. 50, 0, negative 50, negative 100. Yeah, that'll work. 50, 0, negative 50, negative 100, negative 150. 27 would be like here. Negative 133 would be like here. I need a solid dot at both of them. And it's an and, so we're shading in between. So the stuff we're shading, the possible solutions here, are all the possible temperatures on Mars. From 27 down to negative 133, everything in between is possible. That makes sense. It would not make sense to have, if we shaded on the outside, for example, if we messed up and we shaded outside, that would not make sense. There's no way you could have temperatures bigger than 27 and then automatically jump to less than 133 with no temperatures in between. That would not be logical. It would not make sense. Having the solution like this makes sense. Okay. Letter B. It says Spider-Man has either knocked out less than 20 bad guys or more than 85. He got hit on the head by Dr. Octopus and lost his memory. Write and graph an inequality for the number of bad guys Spider-Man knocked out. So it's less than 20 or more than 85. Go ahead, pause the video, write that inequality, graph it, and we'll go through it together in just a second. Okay, so let's see what you did. So he knocked out, so I don't know, I'm trying to think of my variable. S for Spider-Man, B for bad guys. Yeah, we'll use B for bad guys. So bad guys is either less than 20 bad guys or the bad guys are more than 85. So that would be what you should write down for your inequality. And you cannot combine that together into one thing unless you do like bad guys is less than 20 or bad guys is greater than 85. I mean, either way works. The long way or the up and down way, I don't care. And now we graph it. So 20, 40, 60, 80, 100. That'll work. 20, 40, 60, 80, 100. We need a hollow dot at 20. 85 is like here. We need a hollow dot at 85. And it's an or, so we're probably shading on the outside. Bigger than 85. Less than 20. And we're done. Okay? So, how do you solve compound inequalities? What is the key? What have you done in every single problem today to solve these inequalities where there's multiple problems together in the same problem? Pause the video, write down a short little summary, little answer, little sentence or two. Hit play when you're ready to continue. Okay? You should have said something like, the way you solve compound inequalities is you solve each inequality independent or separately, and then graph both solutions on the same number line. Homework, page 384, numbers 12 through 18 even, and number 23. This has been lesson 6.4. Thank you for watching.